Okay.
All right. Hello, everyone. This is Team 2 with our demonstration for Assignment 7. On this call, we have Raghav, Nick, myself, Prashant, Diana, and Dylan. Um, and we're going to demo the osmosis application that we developed for our Assignment 7. So right where we are now is we are in the VM that we have uh, as our deployment artifact for this assignment. And currently we are in the home/group project/osmosis folder location. And what we have in here is, most importantly, we have the osmosis.jar file. And the next most important thing is that we have this directory called scenarios, which has all the test scenario files that we have to demonstrate here. Right. And how we run this application is we do java -jar osmosis.jar, and then as input we can give in one of the test scenario files. So for the assignment 7, we really have only 3 test scenario files here. They are preceded by the A7 underscore. So A7, let's try test 2. So after we do that, that should bring up our UI for this project. And when we bring up the UI, we can see some interesting things here. So first on top, we have like a summary of what's going on with the application. This is kind of similar to the report functionality that was part of the earlier assignments, like assignment 3 and assignment 4. So that information is moved up here. So we have the number of turns taken, the number of grass squares cut, number of grass squares remaining, the lawn size, and then we have some visual helpers that say a blue square means that is the last moved mower, and the red square means a mower is stalled. And in terms of user interaction with this, there are 3 buttons. So one is the next button, one is the fast forward, and then finally there's the stop button. So when we go ahead and click on the next button, the simulation manager tells one of the mowers to perform an action. So what happens is it polls the mower for an action. In this case, it polled mower 1 for an action. It realized that it wanted to do a scan command, and it performed the scan command, and it prints out the percepts that that mower sees onto the console. Similarly, we can go through next a bunch of times, and what we see here is that one turns taken has been changed to 1. This means that all 4 movers in this case have completed 1 action each. So we can continue going through that, and if we continue going through that, I think we should see some stalling behaviors. So let me just go through what's happening. And one more thing that we can notice here is the representation of this square is this is mower number 2. The downward arrow here means it's pointing south, and this number here means it has 25 units of energy. So once a mower performs a move or a scan, its energy is going to reduce. So you'll be able to observe that here. So here, in this case, this mower was trying to move to the square and it was stalled. So according to the scenario file here, the stall count should be 2. So it's currently stalled for 2 turns. So we can click on next a couple of times and we should see that decrement later. So now it is stalled for 1 more turn. And now it's not stalled anymore and it's free to move. Finally, we have this fast forward button, which will go through the rest of the turns for all the movers. That is, the simulation manager will perform the move or scan commands automatically on these movers, and we don't have to click through every time. So finally, what we see is it took in total 22 turns. Number of grass squares cut was 18 when it started with 24. And then that leaves 1, 2, 3, 4, 4 squares which were craters. So 24, 18 plus 4, 22, and then 2 more grass squares remaining, which add up to the total 24 squares. So this is something that might be familiar from earlier assignments, which is the previous report. This is just a different way of showing the same report. We kept aside the terminal here because that was like the log functionality that was expected in assignment 7. Next, what we can do is we can run through another scenario. I can click on the X button here to close that application, and what I can do is instead of test 2, I can run another test scenario, which is test 8 from the same scenarios folder. This is a pretty big lawn, and the mowers all start out from a central location here. Let me see if I can get this window to display more of this content. Okay. All right, it looks like that's the best I'm going to be able to get here. So you can click through the same way, and initially it's all of the mowers perform scan actions, and then they start moving out from their initial locations. Now, one thing that was not observable in the previous run was because the square was very small, the grid was very small, it was not possible to observe the mowers being recharged. In this case, it should be possible to observe the mowers being recharged if we keep clicking on next. And actually, in this case also, it might be a little bit hard to observe that because the mowers energy remaining is pretty high, and it might be a while before they come back to their charging pads. Okay, so in this case, I think, yeah. So in this case, again, this is showing the stalling behavior. Here, the stall count was 3. So it's stalled for 3 turns. And this is one of the cases where you'll probably not want to click next for the entire run of the simulation. Doing the fast forward might be easier. So where it goes through a bunch of where the simulation runs all the actions on the mowers automatically, and here you see how it's you can see how it's one of the mowers. Mower 5 has its energy set to 75, so which was because it moved back to one of the charging pads. That must have been because it was low in energy and it wanted to recharge itself. So in this case, the total number of turns taken was 299. The number of grass squares cut was 74 out of the total 150 minus the number of craters here. Right. So that was.
Prashant, hi. Show the stopping button as well, just because that was one requirement from the customer. So it's very similar to fast forwards. It basically just stops the entire simulation and prints out the logs.
Yeah.
That's the third button.
Yeah, that's a good point.
Implemented.
So what the stop button will do is if the user has gone through a couple of turns, so like the mowers are doing some actions here, if the user wants to stop the simulation, what he or she can do is they can click the stop button and it should print out a report here. So here in this case, we had 150 squares to begin with. Out of those, 108 squares were grass squares. Totally 14 squares were cut, and this was done in 2 turns because there were 6 movers we had. All right, so that was our demo of this um, osmosis application for assignment 7 of software architecture development.